Now let's see the rule of for significant figures in calculation. If we have the calculation, mathematical calculation, then how do you determine the significant figure? For example, if you have multiplication and a division, in that case you will decide the significant figure by the significant figure is sig fig is same as sig fig of smallest sig fig. Okay, let's see that. Okay, same as smallest sig fig involved. There are many numbers you are multiplying or dividing. Out of them, which number have smallest sig fig? We have to round off. We will round up to that sig fig. That sig fig, not that and the decimal value, that sig fig value, not that decimal value. Okay, now let's take one example. 9.2 times 9.2 centimeter times 6.8 centimeter times 0.3744 centimeter. Okay, if you are multiplying these, let's see this side. Let me show you the different color is here. Okay, so different color here. Okay, this is 9.2. how many sig figs? 1 2 sig figs. This has also two, oh, okay, let me see 8 1. Okay, this has 3 sig figs, this has 3 sig figs, this has 2 sig figs, this has 3 sig figs, this has how many? 1 2 3 4 sig figs. 4 sig figs. Which has smallest? 2 sig figs. This has smallest equal to 2 sig fig, right? It means that we will round to 2 sig fig. Okay, now if you multiply these two, okay, 9.2 times, now if you multiply these two, so let's say you have multiplied these two, 9.2 centimeter times 6.81 centimeter times 0.3744 centimeter, and that is equals to, you got how much? You got 23.4225 centimeter cube. But you have to round that up to show that you have a 2 sig figs. Okay, this 23 get you 2 sig figs, right? 1 2, so you have to round that. 4 2 means you have to remove that, right? That's why 23.4225 centimeter cube is equivalent to it. Let's 2 sig figs, no 2 decimal place, 2 sig figs, 1 2 23, done. This is the value, 23 centimeter cube. That's why multiplication of these number gives us 23 centimeter cube, 2 sig figs. Okay, so for example, if you get 9 2, suppose if you get 9 2, then you will write 24, but you have a 2 sig figs. Okay, that's the rule. So that's the multiplication and subtraction and multiplication rule. Okay, now after that, that's the multiplication and the division. Now what is the rule for the addition and subtraction? Now rule number 2, addition, or let me write that, addition and subtraction. In this case, same as like previous, we will see the smallest decimal place. See smallest decimal place and around that, and around. Okay, smallest decimal place and around. Okay, let's see that here, 83.5 ml plus 23.28 ml equals to, now we have to write the sig figs. Now this has how many sig figs? Like, okay, this has how many sig figs? This has 3 sig figs. Okay, this has 3 sig figs, 3 sig figs. This has 4 sig figs, and this is the smallest, right? Oh, it has 3 6 fix and 1 decimal place. 1 decimal place this has 4 6 fix and 2 decimal place. But what is the symbol here? Plus. You are adding that. That's why 6 fix is not useful. You are using the decimal place. That's why you will round off that number up to 1 decimal place. Okay, smallest decimal place is equals to 1 decimal place in this, and that is equals to, you are getting 106.78. now you have to round up to get 1 decimal place. How do you round up? That is to get 1 decimal place, 106.8 ml. That is your answer. So addition and subtraction don't care about the significant figure. That's, you have to see the decimal place. Now rules for rounding of the numbers. Okay, so what are the, you are rounding up, but the rounding up also should have some rule. Okay, now let's see what these rules are. If decimal digit is greater than 1, if decimal digit is greater than 5, if decimal digit is less than 5, but you can have decimal digit equal to 5 also, right? Digit equals to 5. You have 3 things. Okay, so if decimal digit is greater than 5, then what is the rule? Add 1, right? You see that 3.68, 8 is greater than 5, that's why you write what? 3.7. 68 is written as what? 3.7. You add 1 in the previous one. Okay, so if less than 5, just write just previous. So look at that, this 5 is less than, this 4 is less than 5, that's why you just write what? 6, 3.6. But the equal to 5, you have a 2 rule. Equal to 5 if odd, if even. If the number before that decimal 5 is odd, then you will just write that. Okay, even if even, just write that. Oh, sorry. Yeah, if even, just write that. And oh, it's odd. Okay, let me write, it is even and it is odd. Okay guys, sorry. So if even, just write that. If odd, add 1. That is the rule. For example, 3.45, see, this is even, so you will write that is equals to 3.4. and suppose that you have a 3.75, see, 7 is what? Odd, so that's why you will write 3.8. okay, this is the rounding off rule. So this is the rounding off rule. Okay, now let's go to the next sample problem. Okay, now let me show you this sample problem. So let's solve this problem. That is, in A, it is given 16.205 centimeter square minus 1.5 centimeter square divided by 7.081 centimeter. Right? Look at that. It has 2 things. First one, minus, you see, minus, and then divide. When you do minus, then a rule of addition and subtraction, which is what? Smallest decimal place. And this one, division, when you are performing the division, after, first of all you will subtract, then divide, right? You will do that. When you divide, then you go to the multiplication and the division rule, and in which smallest 6 feet, right? Round and round. So that's the rule. Now let's see that how it has been solved. Look at that here. If you see that, these two give you 14.7. okay, after rounding up. Okay, this two, so this is actually what? 16.205 minus 1.5 means 1.5 means 16.205 minus 1.5 14 point. Okay, let me do that here something. Okay, 16.205 minus, what is that, 1.5. okay, 14.705 times, right? That is 14.14. oh, that is 14.705. but this is the subtraction. That's why you will go to the smallest decimal place. What is the smallest decimal place? One decimal place here. One decimal place. You see, this has the one decimal place, right? One decimal. See that it has a one decimal place. So that's why you will write that 14.7. You round that. Okay, 14.7. And this. Now you have division process. Division process. How many sig figs? 1, 2, 3 sig figs. That's why you will round up to 3 sig figs. Okay, let's do that. 14.7 divided by 7.081. 14.7 divided by, what is the number? I forgot, guys. The 7.081. 7. Okay, see here. 7.0. Look at that. 2.0759. Okay, that is actually 2.0759. okay, that actually gives you 2.0759. okay, but you have to round up in such a way that you will have 3 significant figures. This is one significant figure you already have. Okay, this is already a second significant figure. Now you have to round off this, and you round off this, that is 75 means 8, right? That's why you round off this and you will get the 2.0708. okay, so that is this one. And similarly this also, this don't have addition, this has only what? Multiplications and what? Division. And you have to deal with the significant figure, smallest significant figure. It has 2 significant, how many significant figure? It has 3 sig figs. okay, it has what? 1 sig figs. Remember that this has 1 sig figs. okay, but it is 1 by 1000. It is milligram, 1 by 1000, 10 to the power minus 3. That is okay. 0.003. That is 001. So convert that in the decimal place. That's why you have a 3 sig figs. 1, 2, 3. See that? And this is 3 sig figs. This has 3 sig figs. This will also give you 3 sig figs, right? And this has 1, 2, 3, 4. But your answer should have 3 sig figs. 1, 2, 3 sig figs. Okay. So that's why you can calculate the 3 sig figs. Now let's go to the next. This is the sample problem we already did. Now significant figure in the lab. So in the lab, how do I use the significant figure in the lab? In the lab you have similar type of the equipments you have. This is your measuring balance, means weighting balance. Look at that. This has 6.8605. This is the digital equipments and analog equipments. This is analog and this is digital. Okay, this is the digital weighting balance. So in the digital, what is these all are the significant figures, and what is the uncertainty? Always the last digit is uncertainty. Okay guys, last digit is uncertainty. I told you that 6.8605, how accurate it is. Look at that. Wow, very precise measurement, right? Look at that. How many sig figs? 1, 2, 3, 4, 5 sig figs. And this is its uncertainty. Means that what is the uncertainty here? This is 0, this is certain point, this is also certain, this is also certain, this is certain, this is uncertain. This is uncertainty. If this is the digital, it's easy, last digit. But if this is analog, then we have to work whatever we already did. Okay, so how do you know that? You have a 2 idea to know the uncertainty. Uncertainty is equals to, you see, uncertainty is equals to smallest division by n. This is one method, okay, where n is the number of division between 2 points. I will show you here. And other method, other more famous method is this: smallest subdivision divided by 2. That's the uncertainty. Now what will be the uncertainty of this measuring cylinder is, now let's see that 2 points. First of all, between 2 points, 1 point is 50, you see my green, 1 point is 50. Okay, so I think yellow could be better. I don't know. This is another point. Okay, see, orange, two orange points, you see that one point is 50, other point is 60, and there are, what is the smallest subdivision? This is the smallest subdivision, right? Let me take the smallest subdivision by other color, maybe red color. No, the red color, yes. Okay, this is your smallest subdivision. Okay, this is the smallest subdivision. Okay, this is the smallest subdivision, right? Because is there any smaller than 1 ml? Can it measure smaller than 1 ml? No. This will look 50 to 60 means it's 10 ml, right? This is ml. This is the measuring cylinder. That's why it is ml. In 10 ml, how many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines, right? That's why one line means 1 ml. So smallest division means 1 ml. Smallest division means 1 ml divided by how many divisions between these two? 10 ml. Okay, that's why 0.1. Its uncertainty is 0.1. This is one way of calculating uncertainty, but the most people calculate the uncertainty using this way: smallest subdivision by 2. So smallest subdivision by 2. What is the smallest subdivision? Is the same thing. To say the smallest division and the smallest subdivision is the same thing. Okay, what is the smallest subdivision? Again 1 ml by 2, and it will give you 0.5. So this measuring cylinder's uncertainty is 0.5 or 0.1, but this is more famous because 0.1 will be if, yeah, both you can use. Okay guys, now let's see that. Okay, in this measuring cylinder, if you get this value, see, this is the value you get now. Okay, now let me erase and go to the some other highlighting color. Okay, this color is good. Now let's see that. Okay, so here, maybe here. Okay, so you are getting like this. See, this is the meniscus you get. Okay, this is the meniscus you get, for example. Okay, now if this is the meniscus you get, then how do you say that that is a 0.5? Okay, what will be its measurement? See, this is 50, 51, 52, 51, 52, 53, 54, 55, 56, 57. Yes, I can guarantee 57, right? Point, I cannot guarantee. Is that 0.5? Is that 0.5? Is that 0.5 here? It's very close to 51, right? It's not 0.5. No. So you can write 57.1, and this 0.1 is what? Uncertainty. You are not certain, but you are about 0.1, right? You are about 0.1. For example, if you have a this one value, look at that here, this one value, then your uncertainty can be, now what is the 60? This is 60, 61, 62, 63, 64, 65, 66. Okay, 66 is guaranteed. Okay, 66 is guaranteed. 66 is guaranteed. Point, it's a here. You see, it's a here. So let me use that. If that highlighting is good, I don't know. Oh, it's very big. Okay, so let me see that here, show you. Oh, it's even bad. Okay. Okay, let me more color. I think this is fine. Now let's see that here. It's highlighting more. Okay, see, this is just at the half. Okay, let me erase and it's help you. Now look at that. Okay, you see, Now this is, you can say that 55, 56 is guaranteed, and you can say 0.5 now. You can say 0.5, and this 0.5 is uncertainty. This 0.5 is uncertainty. Okay, so that is the uncertainty. So uncertainty tells how many sig figs. Look at that, how many sig figs you have to take 3 sig figs for these numbers. Below 10, 9.5 means it's uncertainty. This number uncertainty. Before 10 ml you have to take 2 sig fig, and above 10 ml you have to take 3 sig figs. Okay, until 99. Until 99 you will take 10 to 99 you will take 3 sig figs, and 0 to 9 you will take 2 sig figs, according to what, 0.21 or 0.5. You decide that. That's your power. Okay, so now that's it. And finally let me revise those things. Okay, so this is the this we just did, and error. Okay, now let's see error again. Let's recall. Okay, error means what? Look at that here in left hand side. Error means actual value minus measured value. Okay, and the percentage error means error divided by actual value times 100. Actual value minus measured value by actual value times 100. That is the percentage error. Now let's take one example. If true value is equals to 2.3 ml, and Harry, that's your teacher, Harry measures 2.01 ml, let's say 2.35. okay guys, let me make the same sig figs. Okay, 2.01 ml, what is percentage error? Okay, now percentage error means what is the actual value? 2.35 minus what is the measured value? 2.01. that is actual value, but I measured 2.01, I have error, right? Divided by what is the actual value? What is the actual value? Actual value is 2.35. 2.35 times 100. So all are, this is the minus. Okay, let me write, these are the 3 sig figs. Okay, 2 minus 2 0, 5 minus 1 4. Okay, 0.4. okay guys, sorry. So 5 minus 1 4, 3 3 3 4, that's it, 0.34. okay, 1 2 3. No, we have to write how many sig figs? 3 sig figs means we should just write 0 here. 340. okay, 340 divided by, okay, let me erase that. Okay, and now, so I don't have place that here, so now let me erase that. Okay, so now, okay, that's good. So now this is equals to what? Okay, this is equals to what I got. Okay, 0.340 divided by 2.35 times 100. I have to write this percentage again, smallest decimal, smallest sig figs, 1 2 3 1 2 3 3 sig figs means it will be 34 by 2.35, right? 34 okay, 0.340 by how much? 2.35. is that really? Okay, 2.35. oh sorry, 2.35 times 100 also. Okay guys, let me times 100 also. Okay, times 100. Okay, actually now I cannot do that. Okay, yeah, so 2.35 times 100, 14.46. so that is actually 14.46. okay, 46%, and that is, let's say round off that, 1 2 3 4, 3 decimal 3 sig figs, that's why 14.46 means 5%, right? This is the percentage error. Similarly, percentage uncertainty means that on total uncertain, okay, divided by the actual uncertainty of your measurement times 100, that is 1. Or just multiply the last digit, you use the uncertainty percentage using the last digit and multiply that with for example, let's say you have a 2.34. okay, what is the last digit? 0.04. multiply that with 100. okay, that is 4%. okay, now 2.1, what is the last digit? 0.1. okay, multiply that by 100, that is equals to 10%. 10% error, 10% uncertainty it has. okay, now and the 2.30531, look at that, what is last? This one. okay, how many decimal places? 1 2 3 4, 1 2 3 4, 0 point. okay, and then 1 times 100 is very few, right? 2 gone, 0.001%. so more sig fix, less uncertain. okay, look at that, less sig fix, 2 sig fix 10% uncertain, 3 sig fix 4% uncertain. see? okay, that's fine. So this is again precision, more sig fix, more precision, less uncertainty, more precise data. What is the precise data? Means how much two measurements are close. okay guys, thank you so much, and this is for today. okay, and the next day we will study some other properties of the matters, and those are even more interesting. Please ask me, you can ping me, you can email me if you like. okay, so I will give you the answer definitely. And when I see you the Google Calendar, it don't work, and many of you actually don't have any feasible time. That time doesn't matter, and we will discuss that in the tomorrow, the next day, and the Tuesday lab. okay, in the lab we will meet on the lab, and be prepared for doing lab. okay, bye bye.